You are all aware of that I'm making a series of videos on nucleophilic substitution reactions. In this aspect, I'm going to discuss S and I reaction in the video. The concept that I'm going to cover in this videos are what do you mean by S and I reaction? What are the mechanism involving in S and I reaction? There are two types of mechanism involving in S and I reaction. The third one is what is the rate of the S and I reaction, and what is the effect of stereochemistry in this S and I reaction. And then finally, what is the effect of solvent in S and I reaction? That means if you use 1,4-dioxane as a solvent, what will be the product stereochemistry? And if you use pyridine as a solvent, what will be the product stereochemistry? Fine. And along with that, I'm going to explain what is the Darzin's halogenation process or Darzin halogenation method. Shall we start? First, let me explain the term S and I. S stands for substitution, N stands for nucleophilic, and I stands for internal. So with this basic thing, let me explain the S and I general reaction. What happens here? That is, when you take an alcohol and it is treated with thionyl chloride to form alkyl halide as a product. And the byproducts are sulfur dioxide and hydrochloric acids. They are byproducts. Now let me explain this S and I reaction mechanism. The mechanism involves two-step process. The first step is the formation of alkyl chlorosulfide. What happens here? This oxygen lone pair electron attacks sulfur atom of thionyl chloride, and as a result the Cl is leaving as Cl minus. So from here hydrogen H plus, and from here Cl minus, they combine together will be leaving as HCl. Hydrochloric acid will be leaving, and to form alkyl chlorosulfate as a product. Right. So once this alkyl chloride sulfate is formed, next step will be, there are two kind of mechanisms are proposed. The first type of mechanism is, from here this Cl taking this electron, it is coming as Cl minus, and it is attacking this carbon atom, and as a result the carbon oxygen bond is getting broken, and this part will be leaving as sulfur dioxide to form this alkyl chloride as a product. So this is a first type of mechanism. The second type of mechanism is, that is intimate ion pair mechanism. Intimate ion pair mechanism. So in this, what is happening? Just a simple thing, that is the carbon oxygen bond is getting broken, and as a result carbon is getting positive charge and oxygen is getting negative charge, right? So this is ion pair will be formed in this case, right? So as a result, what happens here is this electron will be coming towards sulfur atom, and this chlorine will be taking this electron and it is attacking the carbocation to form the alkyl chloride as a product. So that means that mechanism can be given the two type of process. The first process is, that is concerted process. That means this same chloride ion, this nucleophile is coming and attacking this carbon atom. And the second type of mechanism is, this bond, carbon oxygen bond is getting broken and intimate ion pair will be formed, and from that this chloride ion is coming and attacking this carbocation to form this alkyl chloride, right? So let me explain the term why this internal name has come. Right. So if you happen to look at the overall general reaction, you can check here. So this is the OH group, which is substituted by this Cl group. So that means in general the Cl minus should be the nucleophile here, but you are not using any chloride ion containing nucleophile. So what you are using is, that is SOCl to only using, that it will not give Cl minus, that will not getting ionized into Cl minus, right? So this nucleophile is getting generated within the reaction, right? So that is why this is called as internal, right? No, you are not adding any Cl minus containing nucleophile. That means you are not using any chloride ion containing nucleophile, for example sodium chloride, potassium chloride, that kind of nucleophile you are not using. You are using a general reagent, that is thionyl chloride, which will not capable of giving Cl minus, which will not getting ionized into Cl minus. So that Cl minus nucleophile is getting generated in situ the molecule. So that means that nucleophile is generated internally. So that is why we are calling this reaction as S and I reaction. So with this idea, let us discuss what is the rate of S and I reaction. So the rate law has been given here. So what is the slow step? That is the formation of alkyl chlorosulfide is a slow step, and this is the rate determining step. right? So if you happen to check the rate determining step, there are two reactants are involving in this. That means alcohol is involving and this thionyl chloride also involving. So if you happen to look at the rate of SNI reaction is, that is rate is directly proportional to the concentration of alcohol and the concentration of thionyl chloride. Otherwise the rate depends on the substrate as well as thionyl chloride concentration. So that is why this SNI reaction is an example of bimolecular reaction. Fine. So this is about the rate of SNI reaction. Now let us discuss the stereochemistry of SNI reaction. So for the reason, I have taken a molecule here. Let us give the RS configuration of this reactant molecule. So the first priority goes to oxygen atom, second priority goes to methyl group, third priority goes to deuterium, and fourth priority goes to hydrogen. That means 1, 2, 3 is arranged in anti-clockwise direction. The configuration of reactant is S. Now this reactant is subjected to reaction with thionyl chloride. The first step is the formation of chlorosulfite. So that is alkyl chlorosulfite. So from which this internally the nucleophile chloride ion is generated and it is going and attacking this carbon atom from the same side. So that means what happens here, this carbon oxygen bond is getting broken. As a result, sulfur dioxide will be leaving and leading to the formation of this product. Now let us discuss the product configuration. So this chloride getting first priority and methyl getting second priority, deuterium getting third priority, and fourth priority will be given to hydrogen atom. That means 1, 2, 3 groups are arranged in anti-clockwise direction. That means the configuration is S. So the reactant configuration is S and the product configuration is also S. That means same configuration is retained. That is called as retention of configuration. So that is what I have given here in SNI reaction. Always retention of configuration product will be obtained. Right. So now let us discuss the effect of dioxane in SNI reaction. If you use dioxane as a solvent, what will be happening? Right. So again, I'm taking the same reactant here. You can check here the configuration is S. Now this molecule is treated with thionyl chloride. So again the rate determining step is, that is formation of alkyl chlorosulfate. Right. In the next step you are using 1,4-dioxane. So this is known as 1,4-dioxane. 1,4-dioxane. When you use 1,4-dioxane as a solvent, what happens here? This lone pair of electron on oxygen atom is attacking the carbon atom from opposite to the leaving group. So you know that this part is the leaving group. I have already explained in SN2 reaction, always a nucleophile will try to attack opposite to the leaving group. So this leaving group is present at right hand side, the nucleophile will approach from the left hand side. So once it is attacking, means what happens in the next step, that is this bond getting broken. And this Cl will be taking electron and leaving as Cl minus. So from this SO2 sulfur dioxide will be leaving and chloride ion will be leaving. Fine. It leads to the formation of this intermediate. Okay. So here the oxygen will be carrying a positive charge. Since it has donated a pair of electron, it will be gaining positive charge. In the next step, what happens here? This Cl minus is attacking from this side, opposite to the dioxane part. Once this attack is taking place, this carbon oxygen bond is getting broken and from here dioxane will be leaving and leading to the formation of this product. So you know that the configuration of the reactant is S and the configuration of product is also S. So in the conclusion is, if you use 1,4-dioxane as a solvent in SNI reaction, the reaction takes place through retention of configuration. Configuration will not change, right? Next one, what is the effect of pyridine in SNI reaction? So I have given the same reactant. So the configuration of reactant is S. Now this is treated with thionyl chloride. The first step is the formation of chloroalkyl sulfate. Right. So once it is formed, now the second step, pyridine will come to the reaction. So what happens here? The lone pair of electron on nitrogen atom will come and attack the sulfur atom. As a result, the Cl is taking electron and it is leaving as Cl minus, and leading to the formation of this type of intermediate. Fine. So what happens here? This chloride ion, now this part becomes a leaving group. So this part becomes a leaving group. Now this leaving group is present at right hand side. Now the nucleophile here is, that is chloride ion, will be attacking from the left hand side, opposite side. So what happens here? So this chloride ion will be coming and attacking here, and as a result this carbon sulfur bond is getting broken, and this electron will be moving towards nitrogen atom, and as a result what are the species are removing? That is sulfur dioxide will be removing, and as also pyridine will be removing, and leading to the formation of this product. So if you happen to look at the configuration of the product, that is, this is getting 1, 2, 3 and 4. Now this 1, 2, 3 is arranged in clockwise direction. The product configuration is R. So the reactant configuration is S and the product configuration is R. So that means you are getting opposite configuration products. So this concept is known as inversion of configuration. So if you use pyridine as a solvent, that the reaction will give inversion of product, and this process is called as Darson's halogenation, otherwise known as Darson's process. So the Darson process involves the alcohol which is treated to thionyl chloride along with pyridine to give alkyl halide as a product. But in this case, if the alcohol is having a chiral center, means you will get the inversion configuration product will be formed. So that's all about the SNI reaction. I hope the video is very much useful to you. Meet you all in the next video. Until then, take care. Bye.